Good afternoon, everyone. My subject is cable structure. Here is the context. History of the structure. Within the context of the built environment, the term structure refers to anything that is constructed or built from different interrelated parts with a fixed location on the ground. The history of the structural engineering dates back at least 2700 BC, when the step pyramid for Pharaoh de Jures was built by the Imhotep. Here is the architect, and here is the step pyramid. The single-story long-span structure separated from the four titles. These are the form-active system, vector-active, section-active, and surface-active system. The form-active structures are structures like domes, cable nets, that are sometimes flexible and either shaped or of material such that under load no bending stress exists, only compression and tension stresses. Example of structure: arch, tent, pneumatic, cable, and shell structures. Here is the cable structures. The carrier system, in which the main loads of the structure are carried by the tension element between the anchorage points, are defined as cable system. Cable structure, form of long span structure that is subject to tension and uses suspension cables for support. A cable is a flexible, bendable, linear carrier element with almost no bending stiffness and compressive strength. It can be the main element of the carrier system, also used in the cable structures. It can be produced from steel wires, non-metallic organic fibers, or plastic derivatives. And here is the cable section. Fully enclosed wire group, half closed wire group, and the steel ropes. The construction elements of cable structures: node points, hanging points, end of cables, net H element, support staff, anchors. It's necessary to anchorage the carrier system, trying to pull it to the ground. These are the carrying the load from the ground. It's important. And the general technical specification of cables. And here is the join element. These are the switch open sockets, switch closed socket. This is hanging off the cable to the support elements. Here is the support elements. Here is the cable, hanging point, and the connection point with the support and the hanging point. Here is the join element, cable bend. Strength is also the words main is like cable. Standard socket and the cable bend. Cable structure working. Cable system allow the passage of large openings with the bearing advantage created by the curved shapes and the pulling effect of the cables. Let's understand the cable's loading mechanism between the two fixed and with one single load at mid-span. As you can see, two fixed and the one mid-span. Under the action of the load, cable assumes a symmetrical triangle shapes. The load is carried to each support by simple tension. Variation of cable reaction with sag. Tensile stress in the cable increases with the decrease in sag, and it decreases with the increase of sag. As a result of cable sag under the load, the sag increases, the pulling force on the cable decreases, the reaction forces in the artificates become smaller. The reaction forces and internal forces are inversely proportional to the sag distance. Long-term strength deformation occur in cables that are under the load for a long time. For this reason, cables must be subjected to certain hourly tests during the production. Here is the cable state under the tension and the compression. The classification of cable structure is the separate for main title: parallel cable system, radial cable system, cable network system, and the cable trusses. Cable network system also the separated three main titles from each other. These are the single curvature and the double wide, the double curvature. Here are the parallel cable system. The system is decorated by hanging steel cables on fixed support points in rows parallel to each other. There are cover, edge, support, and anchorage elements. Here is the support element. It's here is the anchorage element, here is H, and the cover element is also, you can see. Here is the rigid support element, also here. It's the use of tension ropes to stay in the same plane with the carrier cables, partially above, below, or partially below these cables. And however, in these cover shapes where steel cables are freely stretched and form a chain curve, as a result of the increase of air pressure in the interior volume, the steel cables make a fluctuating movement towards the outside because the cover system is also light. To prevent this fluctuation, the covering system can be made heavy. The radial cable system. They are formed by stretching steel cables in radial positions. The tensile force in these cables, which form a synclastic surface, are met by pressure and tensile rings, as you can see, compression ring, stabilizing cable, suspension cable, and the tension rings, separated struts, and the columns. Some cast dome is the example of the radial cable system. The lifting forces are met from the pressure ring by compensating a cable pattern similar to the upper tension ring. These opposing pairs of cables and two tension rings in the center are separated by vertical brace. Pressure ring is reinforced with the concrete and supported by the surrounding columns. You can see from the picture. The cable network system. The balance stability of the system is provided by the cables arranged in the opposite direction. Generally, steel cables lined parallel between two supports. The system becomes stable with the tension cables that are stretched in the opposite direction. Here is a single curvature. Single curvature structures consist of two or more parallel layers of energy cables spanning between primary supports. Here is the example of the Ingalls hockey field. This structure is connected to a single concrete backbone with a steel suspended cable grid system and a flexible surface. In addition to the resistance bending between the transverse cables, the wood flooring tries to pull on each side. With the non-longitudinal compensating cables to resist to the buoyancy of the wind. As you can see, double cables are similar to single curvature systems, with the addition of the compensating cables under the primary suspension cables to compensate for the lifting effect of the wind. Here is the suspension load and the balancing load. Denver International Airport is the example of the double cable system. Double curvature. The double curvature structures are anti-rubber, so that the suspension cables are sprayed between the supports in one direction, while the compensating cables are the vertical direction and pulled down to prevent the buoyancy of the wind. It's also called biaxial. It's an example of the biaxial system. Relay arena. Two-way cables in the quaternary system, rigid bent, and two parabolic. It's the stretched between the arcs. The primary hanging cables, also cable trusses, can be described as a system of the straight bars and the cable join at their ends from a rigid framework. As illustrated, the objective is to transfer applied loads to the support in the form of axial force. Here is the cable structure using the aircraft hangar example. Famous cable structures, companies reference. Thank you for listening.